Hey everyone, welcome to Fab and Science. Today we are going to dive into one of the most fascinating and essential forces around us sound. From the music we love to the voices we hear every day, sound is everywhere. But have you ever wondered what sound actually is or how it travels? Stick around and let's find out. Learning objectives are as follows. You will be able to understand the nature of sound, learn about how sound travels, its properties, and its uses, explain about the speed of sound. So let's start with the basics. What exactly is sound? Sound is a form of energy that's produced when an object vibrates. When that object moves, it causes air molecules around it to vibrate as well. Those vibrations travel in waves, and when they reach our ears, we perceive them as sound. But without these vibrations, we wouldn't have any sound at all. But here's the big question: how does sound actually travel or propagate? Well, sound needs a medium like air, water, or even solids to move. It can't travel through a vacuum like space because there's no material for the sound waves to move through. And here's a fun fact: sound actually travels faster in solids than it does in air or water. That is why, if you put your ear to a wooden table, you can hear someone tapping on the other end before you'd hear it through the air. Now, let's talk about the three main properties of sound. The first one is pitch. This is how high or low a sound is. For example, a high pitched sound might be a whistle, and a low pitched sound could be the deep rumble of thunder. Second property is loudness. This is how intense or quiet a sound is. A loud shout has more energy than a whisper. Third property is timbre. This is the unique quality of a sound that helps us distinguish between different sounds, even if they are the same pitch and volume. Think of a piano and a guitar, both playing the same note. They sound different, right? That's timbre. Now we are going to look into how properties of vibrations affect the properties of sound. First up is pitch. Pitch tells us how high or low a sound is, and it's directly proportional to the frequency of vibrations. In simpler terms, higher frequency is equal to higher pitch. For example, think of a baby crying, sharp, high pitched sound. Lower frequency is equal to lower pitch. For example, like a deep roar of a lion, low pitched and powerful. Next, let's talk about loudness. Loudness depends on the amplitude of the vibration. Greater amplitude, louder sound. Example, music blasting from speakers at a party. Smaller amplitude, softer sound. Example, a gentle whisper in a quiet room. Now, here's something cool: timbre. Timbre is what makes each sound unique, even if pitch and loudness are the same. For example, play the same note on a guitar and a piano. They might have the same pitch and volume, but they sound completely different. That's because timbre depends on the source of the sound. So, to recap, pitch depends on frequency, loudness depends on amplitude, timbre depends on sound source. Pretty cool how vibrations shape everything we hear, right? All right, it's quiz time. Here's the first question for you. What determines the pitch of a sound? Is it A, amplitude, B, frequency, C, speed, or D, temperature? Take a second to think about it and pause the video if you need more time. Ready for the answer? And the correct answer is B, frequency. The faster the vibrations, the higher the pitch. Great job if you got it right. Now let's talk about how fast sound travels. The speed of sound depends on the medium it's traveling through. In air, sound travels at about 343 meters per second. But in water, sound moves a lot faster, around 1482 meters per second. And in solids like metal, it travels even faster. Cool, right? That's why you can sometimes hear things before you see them, especially if the sound is traveling through a solid medium. How do we use sound? Sound isn't just for hearing things in the environment, it's also incredibly useful in technology and medicine. For example, doctors use sound waves in ultrasound to look inside your body without cutting you open. Sonar uses sound to detect things underwater, like submarines or fish. And of course, we use sound every day to communicate with each other, whether it's on the phone or in person. Sound is everywhere. All right, time for another quiz. Which of the following uses sound to create images inside the body? Is it A, X ray, B, MRI, C, ultrasound, or D, CT scan? Pause if you need a moment to think. And the correct answer is C, ultrasound. Great job if you've got it right. To wrap it all up, we have learned that sound is a form of energy produced by vibrations and it needs a medium to travel through. It has key properties like pitch, loudness, and timbre, and it travels faster in solids than in air. So, next time you hear a sound, you will know what's going on behind the scenes. Thanks for watching. If you enjoyed this video and want to learn more about how the world works, don't forget to like, subscribe, and hit the bell icon for notifications. Drop a comment below to let me know if you have any questions about sound. See you in the next video.